Okay, so this is going to be our review for the exponent rule quiz that you're going to take here in a little bit. This table that's at the very end of your note packet, I want you to cut it out before you start filling out anything. Okay, so if you need to pause this, go grab some scissors, cut this table out, then go ahead and put your note packet away and restart this video. So we're going to go through each of the rules, and I'm going to give you an example for each of the rules, and you're going to use this table on your quiz and staple it to the quiz when you turn it in. Alright, so for the first rule here, we have product of powers property. So that's when we are multiplying two terms together. Okay, when we multiply two terms together, we are actually going to add those exponents. Okay, we'll multiply any coefficients, but we'll add our exponents. So over here in our example, we have 5a to the third power times 2a to the fourth power. So we're going to multiply the coefficients to get 10, and then we'll add our exponents to get a to the seventh power. Alright, so product means we're multiplying the terms together. So multiply your coefficients, add your exponents. Next one, power of a power property. This time we have an exponent inside parentheses and outside parentheses. When that happens, we're going to multiply those exponents together. Alright, we're basically distributing that exponent that's outside parentheses to everything inside. So we'll distribute the 3 to the 2, the 5, and the 2. So 2 to the third power means 2 times 2 times 2, which is 8. And then we'll multiply those exponents. So 5 times 3 gives us x to the 15th power, and 2 times 3 gives us y to the 6th power. Okay, so exponents inside and outside, that's when you multiply those together. This third rule, power of a product property, is very similar to what we just did. We're distributing that outside exponent to every single base inside. So that means any coefficients and any variables. So example is pretty similar. Distribute that 2 to everything inside. So 3 squared means 3 times 3, which is 9. Then we are going to multiply our exponents. So 4 times 2 gives us a to the 8th power. And then we'll multiply the 5 and the 2 to get b to the 10th power. Okay, so if you have multiple terms inside parentheses, now we're distributing that outside exponent to every single thing inside. For our fourth rule here, power of a quotient property, again, same thing applies, but this time we have a fraction inside parentheses. So we're still distributing everything, but now we're just going to distribute it to a fraction. So we'll get a to the m power over b to the m power. So with our example, we have 4x to the third power divided by y to the fourth power. That entire thing is being squared. So we'll distribute that 2 to everything inside. So 4 squared means 4 times 4, which gives us 16. And then we'll multiply our exponents. So 3 times 2 gives us x to the 6th. And since that x started in the numerator and we got a positive exponent, we're going to leave it there. Then we'll multiply 4 times 2. So 4 times 2 gives us 8. So in the denominator, we'll have y to the 8th power. Again, since that y started in the denominator, and when we multiplied we got a positive exponent, that y is going to stay in the denominator. Alright, next one, quotient of powers. So this time we're dividing our two terms. That's what our fraction bar right there tells us, dividing. When we divide our two terms, we're going to subtract those exponents, m minus n. Okay, so we'll reduce any coefficients, divide those, and then subtract our exponents. So for our example, we have 3x to the 7th, y to the 5th power, divided by 9x to the 3rd power, y to the 7th power. So we're going to start by reducing our coefficients. So 3 divided by 9 leaves us with 1/3, so we have 1 over 3. And then we'll subtract our exponents. So 7 minus 3 gives us a positive 4. So when we get a positive exponent, that variable goes in the numerator. So we'll have x to the fourth in the numerator. And then for the y's, we have 5 minus 7. 5 minus 7 gives us a negative 2. When we get a negative exponent, that tells us our variable is going to go in the denominator, and that's where the exponent will be positive. So when you subtract and you get a positive, same way we got positive 4, that told us the x goes up top in our fraction. When we subtracted 5 minus 7, we got a negative, so that negative tells us the variable will go in the denominator, the bottom of our fraction. All right, so the negative power, we just kind of talked about that a little bit, and we're going to switch up how they wrote the rule in this table to start with. They started with a positive exponent, and they want us to simplify it to make it negative. We would never do that. We would start with the negative exponent, a to the negative n power, like I wrote here, and we would simplify it to become positive, which would be 1 over a to the n power. All right, so just cross out what they originally had there, and start with a to the negative n, and then we simplify it to make it positive in the denominator. So just like we did in that last problem, we're going to do the same thing again here. So start with your coefficients. We divide those coefficients. So 16 divided by 4 leaves us with 4 over 1. You don't have to write that 1 in the denominator. You can. I won't take off if you do or if you don't. And then we're going to subtract those exponents because they're on opposite sides of the fraction. So 3 minus 8 gives us a negative 5. So since we have a negative, that tells us the variable goes in the denominator, and that's where it becomes positive. So we'll have a to the positive 5th power in the denominator. Then for the b's, we have 9 minus our invisible 1 there. So 9 minus 1 gives us positive 8. And since it's positive, that variable is going to go in the numerator. So we'll have b to the 8th power in the numerator. And then lastly, for the c's, 6 minus 6 is 0. So that means we don't have any more c's left. Those two cancel out. So no c's left in our answer. All right, so again, when your problem is a fraction, you divide your coefficients, subtract your exponents. When you subtract, if you get a positive, it goes in the numerator. If you get a negative, it goes in the denominator. And then lastly, we have our zero power property, which we talked about last class period, where anything to the 0 power becomes 1. Okay? Same way that these c's canceled out over here. We could put a 1 in its place, but anything times 1 is going to be what you already had, so there's no use in putting a 1 over a 1. Okay? We could do it, but we don't have to. All right, so I have this big problem here. 5x to the 13th power, y to the negative 4th power, z to the 32nd power. So that entire thing is being raised to the 0 power. So no matter how many terms are inside, if you're raising all of that to the 0 power, your answer is still 1. Because basically all of those terms are canceling out. So when we don't have anything left, we put a 1 in its place as a kind of as a placeholder there. Okay? Take your time if you need to go back through this video, re-watch some of the explanations, make sure you have everything written down because you can use this table on your quiz here in a little bit. All right, and then I'll have a second video for some extra practice problems for that mixed practice we talked about last time.